we are interested in developing fabrics, woven, woven weaved type sort of product sort of formats. But if I start on the actual products of where we're positioned right now, I'll actually start on the right-hand side of this page, where in aerospace we are fully commercial at the moment with our polyketone sort of materials, and the compatible overmolding materials from Solvay are also referenced. So Ketaspire is Solvay's PEEK sort of material for injection molding. We then move a little bit into PVDF, where we're developing very strongly in the oil and gas sort of market. A lot of deep sea requirements and driven really by lightweighting. So Solvay are really industrializing applications based on PVDF, carbon fiber tape, and those should be entering the market commercially very, very soon. But then we move on to the left-hand side of the page, and these are the two product families which do have a fit in some other market segments, but the PPS and the PPA product forms are those that we are basically developing with an eye on automotive. Some of the other icons at the top here, so the car is obviously automotive, the plane is aerospace, the oil rig is the new energy sort of sector. But another area that we're spending a lot of time on is in the urban air mobility. So these are the core market segments where Solvay are focusing our efforts on sort of thermoplastic composites. So where they, as I say, where they fit is where the more classical engineering sort of thermoplastics cannot provide that technical performance. So we're mostly looking a little bit more on more structural and maybe some more niche sort of applications. And when you're looking at those type of applications or those sort of customers, you need to be enabling the customer to feel confident, have the trust, have that credibility of what you're developing. So this is where the MSAC, as we call it, the Material Science Application Centre in Brussels, this is where Solvay want to collaborate with customers. We don't want to make parts. We just want to enable our technology to be adopted. And this is where we've had a very close collaboration with Engel in a lot of machines that we have within the application center are Engel sort of machines. Again, the three pillars that we want to work on is virtual engineering, both in the solid and the molten state. So if you can't actually prove the design in the virtual world, then you can't really move forward today into real world sort of applications. So once we're putting a lot of work on the expertise around virtual engineering, both on macro and part scale sort of simulation. We then now have equipment where we can prove out a lot of the the technologies that we're working on. This could be tape cutting, it could be 3D stamping and overmolding, it could be blank consolidation. So we have processing equipment that is in place that we can work with our customers. And then also we have a very detailed investment in part testing. So we can do a lot of high speed sort of testing, for high strain rate or impact sort of applications, particularly when it comes down to crash sort of simulation. So we can do a lot of work on our materials in this particular sort of area, which is something that I think is needed when we're talking about composite, multi-material sort of structures. We also have a multi-axial testing platform where we can really do some really detailed, sort of structural analysis. And also then we have more non-destructive sort of testing. So these are more digital or X-ray or thermography. So we can really understand the quality of the part as well through some non-destructive sort of testing. So this is really the foundation of what we're working on. We're working on really high performance thermoplastic composite materials with overmolding. We have a desire to collaborate with the industry and with different partners to accelerate these sort of solutions into the market. This is why we have this application center. But what I said, I know this is a lightweight in day, but in the applications that we are typically looking at, I would say that lightweighting by itself is not enough of a value proposition. It is important, Obviously, e-mobility applications tend to be a little bit heavier than internal combustion engine equivalents, but the lightweighting by itself isn't enough. We have to drive more value driven by the design flexibility, the part integration, the rate of manufacture, etc., that comes from a thermoplastic solution. So I just wanted to end my presentation to try and keep us on track, to highlight 3 examples of how these materials are being used. The first was referenced in the previous presentation. So this is a long fiber injection molded product. So it isn't a short fiber product. So this is made by pultrusion. So it's a continuous fiber, and then it's put through a strand die and cut into pellets, which is shown an example on the picture there. So we worked with Stajvelo to make the first all injection molded polymer e-bike. So the long fiber technology does give that performance bridge between the short fiber materials and the continuous composite sort of materials. So this is an example of, I guess, a mature technology, which is injection molding. It's not a short fiber, but it's a long fiber sort of material. The next 2 applications where I wanted to finish the presentation, these next 2 examples aren't commercial. These are more demonstrators or conceptual sort of work, but I think it will hopefully give you a flavor of the type of work that Solvay are doing to advance these high performance sort of materials. The first of these is in e-mobility, particularly in the electric drive unit of electric vehicles. We see at the moment that in the picture here, you have a motor housing, you have an inverter housing, you have a gearbox housing, and they're all separately sort of bolted together. So what we see from discussions with OEMs, that we see in the future, the integration of these components sort of all together. And what we feel is this is a potential benefit for high performance thermoplastics. We're talking of temperature ranges going up to around 80 to 100 degrees. We think our material portfolio really will help us optimize the lightweighting potential, but also we can integrate much more functionality into the part using a thermoplastic design. So if you just look at the motor housing by itself, if you just focus in on that, then it's very difficult to get a strong value proposition. But if you zoom out a little bit and you look at the system requirements, you can then start integrating a lot of functionality, reducing part counts, driving a lot of value that you can get from these types of materials. So what Solvay are doing is, right at the moment, we're working with a consultancy who are skilled in the art of e-powertrain design. We will be coming up with a conceptual design for an integrated gearbox housing. That will be ready by the summertime of 2021. And we then aim to make that as a demonstrator part in our Brussels facility by the end of this year. So it's a good demonstration of how this technology can be used. The final application that I wanted to highlight, which is very much, I see a lot of information being focused around battery enclosures. What I would say is that a lot of the incumbent designs, the base, the metallic base, takes a lot of the crash and structural loading, and therefore a lot of polymers and SMC materials used on the lid. And what I read and infer from that is that the composite material is being sold on lightweight and on cost. Whereas what we have done in this project, again, we've worked with a different industrial partner, again, skilled in the art of battery enclosure design. We wanted to make the case for a full thermoplastic composite multi-material battery enclosure. So this is more of a full composite stamped with more localized overmolding. So the image, this is our conceptual design. That the lid is transparent, so you could see the modules underneath. But the real reason was to really identify the performance benefit of a composite design beyond just lightweighting, so we can take the full advantage of the materials that we're working with. And what was very important when you want to try and start sort of brainstorming around this is that you need to have a mission statement. And our partner told us that the key thing that OEMs are interested in at the moment is improving the energy density. How do we get more space in the battery enclosure for what's important, if you like? And what we see from a lot of the incumbent steel design is what's in their design takes a lot of internal volume. And when you can change from first principles, change that design to use the materials that we're talking about, you actually can end up with a very significant increase in energy density, not only in watt-hour per litre, but also watt-hour per kilo. And even though our design driver was purely to improve energy density or package, we still enabled to have a 60% reduction in weight. So the steel solution, this was a premium EF vehicle segment. So the steel solution was 140 kilos in the enclosure. So we managed to get 60% reduction in the weight. And this is at a conceptual sort of phase now. We're working on the safety requirements as well with our composite materials for the China. We have thermal management simulation capabilities, and we're working on shielding sort of R&I projects as well. So this is something that is ready, and we're starting to just engage with the market. But again, I thought it was a really good example of how using the right design with the right materials, you can really get a significant improvement in benefit versus incumbent steel solutions. So my final really conclusion slide is that Solvay's ambition is to try and be an industry leader in thermoplastic composite technology. We really believe that innovation and collaboration is really important. And that's why I'm very sort of grateful for Engel for how we're working within our application center. But also you need to validate all these ideas, all these applications to get that trust and credibility. And Solvay really does believe that the next area for us to focus on are some of these more structural e-mobility sort of applications. So if there's an interest of following up with me sort of afterwards to go into a little bit more detail of what I've spoken about, here's my email address. And if we have time, then I'm more than willing to answer questions at this moment in time.
Okay, Dr. Wright, thank you very much for your nice presentation. We actually have several questions, and we will just start with them right away. There was a question about rough order of price per those materials, especially the PPA. Can you comment on that here, or is it probably really depends on the amount, right?
Yeah, I mean, absolutely. Then what we're trying to sort of work on is that
Dr. Wright, might you close your presentation? Yeah, then you can see.
Yeah, sorry. Yeah. Stop sharing. Is that working now?
That's perfect now. Thank you.
Yeah. I think talking specifically about price of individual materials isn't. I think we're trying to look at the total sort of cost of ownership to make sure we optimize the design. I mean, if there's specific interest, then if someone wanted to contact me, we can get into a little bit more specific details around price. But we're trying to use an optimized amount of composite with the injection molded material to get a good total cost of ownership, shall we say.
Yeah, that's probably a good idea to contact you directly then. And another question, have you investigated the recycling or reprocessing of these high temperature material composites?
Yeah, we've definitely started to look at those, particularly in that battery enclosure. We're not going to use 100% of all the composite, sort of material. There's always going to be some wastage. So the idea is that can be recycled into some of the overmolding material that we can then use in the component. And obviously, being thermoplastic, sort of materials, then of course they can be recycled. I think we focus more on the concept, and we need to spend maybe a little bit more time just answering all the questions on the recyclability sort of elements.
Thank you. And at the end, I also have a personal question out of my interest. Why do you think that your concept for this battery housing that you presented, why do you think this is different? What's new there?
Well, I think when you see all the current designs, the base in the metal designs take all the loading. And the lid is really just there to be lightweight and maybe do the thermal runaway. So what we have looked at is trying to integrate the most important thing about the mission statement was to make sure we wanted to focus on the package space. So actually, we have more of a clamshell design where it's the lid and the base are all functioning, both contributing, if you like, to the crush and crash loading. And also we can integrate the underfloor protection into the base as well. So we're minimizing the number of parts. So I think in the steel incumbent part, there was over 20 parts. We're essentially bringing that down to single figures. So we're really simplifying, the manufacturing approach. And when you do that, you can really integrate features, and therefore you leave more space on the interior of the battery for what's most important, which are the cells and the modules.
Yeah. Okay, perfect. Thank you very much for your answers. And that's it. That was our morning session. Norbert, what do you think?
About the morning session?
Yes. Did you like the program?
I really liked it. So we had so many things. We had automotive. We had a lot of sports goods contained. Yeah. But the question we ask ourselves often is, what will be the drivers for the future? What will bring us large-scale applications? So where numerous components, lightweight components, will be needed in the future. So perhaps both sports goods should be something which shouldn't be underestimated. Sometimes we see them quite quickly in the market. So what's your impression?
I think it's important to consider sustainability, and we've seen it in today's talks. We have had many questions in this direction, and for us at Composites United, sustainability is a key reason to do lightweight, to be lightweight. Not necessarily always with composites. We've seen other great solutions as well, but in overall to save weight, because I think personally lightweight design is a key to address, or a key technology to address the climate change challenge that we are facing right now. And we need to be more efficient. We need to use less materials. We need to save energy. So that's very important. And I think in the afternoon session we will touch base on this topic again. I'm fairly certain.
Sustainability was mentioned several times this morning. I think this is something we need to be concerned about in the future. And this is where we will start the afternoon session. But now it's lunchtime. We will start again at 12:50, and for the lunch break, we have prepared something.
Yes, so I think it's important, ladies and gentlemen, after sitting in front of your screen for hours, you get tired, right? So you should get some energy, have a nice meal. But honestly, you don't really need an hour for your meal, probably. So we have a little surprise for you, a nice video where you can move, where you can get active, energize again. And then we are very happy to welcoming you again for the afternoon session at 12:50. And we will go down this route with you, continue through this great exhibition. And I look forward to see you again.
Yeah, and have a short glimpse on the video. And when you like it, just give us a short feedback.
See you later.
Jerusalema ikhaya lami ilondoloze uhambe nami zungangishilana Jerusalema ikhaya lami ilondoloze uhambe nami zungangishilana dawo yami ayikholana buso wami awukholana ilondoloze zuhambe nami dawo yami ayikholana buso wami awukholana ilondoloze no indawo yami ayikholana, buso wami awukholana. Ilondoloze